Hello everyone, this is Jabal Sonisha. My register number is URK23CS1119. Today I'm going to explain you about my experiment number 4 in MLT. First, I'm just going to import all the libraries which I wanted in this experiment. My first question is to read the CSV. To read, I'm just using read CSV function and printing the head of the dataset. My second question is to do necessary pre-processing data imputation with mean for null values and enable encoding for categorical. So for that, I'm just filling it with mean value, using filna, mean imputing with mean value. Label using and label encoding, I'm just transferring, converting categorical value into numerical value. My third question is to choose independent variables x1 and x2 and dependent or target variable from given dataset. For x, I'm just giving bill length bill depth, flipper length body mass values as x, and y for y species dot values. I'm just going to mask it. The mask is df species equal to idly idle. So my big X value is the X which we masked, and the Y is the Y mask value. Y is equal to 0 0. The Y is should be minus 1 to 1. Then we are going to standardize the input features. For that, scalar, standard scalar of scalar dot fit transform, printing the X values. So this is going to be the output. Then we are going to split the data into training and testing using scikit-learn model selection, importing train test split. For that, splitting test size is equal to zero point 0.2, random set is equal to 42. The next question is to assign the learning rate, number of iteration, initial weight, and bias. For that, learning rate is 0.1, 0.01, iteration height 100, n samples, and n features equal to extend dot shape of. For weight, I'm just giving zeros of n features, bias 0, and error. The next question is to calculate the updated weight in every iteration during training and display the final weight of each input attribute after the training. For that, giving error value of 0, iterating it with idx and xi with training data. Linear output is dot of xi and weight plus bias. Predicted is 1 if linear output is greater than 0, else minus 1. Update the learning rate into y train idx minus y predicted. The weight formula is weight plus updated x update into xi. The bias is equal to bias plus update. If the update is not equal to 0, the error is equal to error plus 1. And we are appending the error in the column which we created and printing the bias and the weight. So this is going to be my output. The next question is to plot the graph for iteration against error during the training. For that, plotting it in the range iteration and errors using line plot and giving x label and y label and showing it up. My 10th question is to predict the class label for test set. For that, I'm just creating a column by predict. And for x test in x, linear output is x w weight plus bias. Prediction 1. If the prediction value is 1 if the linear output is greater than or equal to 0, else it is going to be the minus 1. So y predict value, we are appending prediction into the y predict, and y predict is equal to array of y predict of values and printing the array value. And 11th question is to display the confusion matrix, calculate the performance matrix, accuracy, precision. For that, confusion matrix we are imported in the libraries. For that, using confusion matrix, y predict and y test. Classification also y predict, y test, accuracy score, y predict, y test, printing precision score likewise, and recall and f1. So this is going to be the output. Thank you.